Now let's take a look at our figure 17-2 from Stallcup's Electrical Design Book, Volume 2. And we're going to pick up wiring methods that could be used in high voltage systems where the voltage is over 1,000 volts typically. Now, notice that in the note here in the illustration, you have wiring methods there, and 300.7 deals with these wiring methods that are above ground. The 300.50 deals with wiring methods and raceways and cables and so forth that's in the ground. Now, basically, the ampacity of the conductors that you see in the illustration are obtained from the new Article 311, and you select a table based upon the type of installation you're making with high voltage, where it's cables, raceways, raceways in free air, raceways with conductors in the ground, and so forth. And of course, you know that Chapter 3, the 300 series, deals with a particular wiring method such as rigid metal conduit, abbreviated RMC as Article 334, etc. And you have approximately about 12 or 13 wiring methods that are listed that could be used for service entrance conductors when you're dealing with high voltage. The new Article 311 also contains the old existing article for medium voltage, Article 338. Now, but when you start picking up components to use with these wiring methods, switch gear, switchboard, panel boards and things like that, circuit breakers, fuses arrangements that you might want to use for protection, you have to go to Article 490 for those. So you're using Article 311 for the ampacity of conductors, and you're using also the requirements in 311 that used to be in Article 328 for medium voltage, but you must go to Article 490 to select the equipment and the components to make up a high voltage electrical system. Now, this figure 17-2 illustrates the wiring methods that you could use with service entrance conductors in accordance with NEC 230-202. And then, of course, we have the wiring methods selected for you that if you wanted to look at them very quickly. 300.37 if your high voltage system installed above grade, and 300.50 if it's installed in the ground. And that's what this figure 17-2 is illustrating.